Welcome back to another session on robotics. As you all know, robots are smart enough to detect obstruction, and also with respect to having to move in certain direction, there is a place of sensing. There are different means with which a robot can actually sense distance. A very good way is actually ultrasonic sensor. This actually deals with sound. As you can see with me here, is actually an ultrasonic sensor, HCSR04. How does ultrasonic sensor work? Basically, you must have been into an empty room before, and when you make any sound, it definitely echoes out. That is actually based on the principle of reflection of sound. As you can see on this circuit, which is going to be displayed above, as you can see currently on this particular terrain with respect to HCSR04, you have the VCC, which is actually the positive terminal, the trigger and the echo, then you have the ground. These pins are connected to pin 9 and 10 respectively, and any of the digital pins can actually be used respectively. So we might want to demonstrate how this works basically. First thing first you might want to do, as it's being displayed on your screen, is definitely to define the different pins. That's actually the trigger and the echo pin. Then next, you actually try to have the setup that is the trigger is actually the output pin, while the echo is actually the input pin. Then set a baud rate. The baud rate is actually to indicate the rate at which it's going to be displayed on your serial monitor. This first probe actually goes to ground, which is actually your 0 volts. Then this other one actually goes to what? Goes to 5 volts. Your echo pin basically goes to pin 10, while your trigger pin actually goes towards pin 9. The next thing I want to do is just to get this code into this particular microcontroller, which actually your Arduino board basically. So we'll wait. It's currently compiling the sketch. After compiling the sketch, it's definitely going to upload it. It's currently uploading, and once it is done, we actually monitor the distance between this particular entity and this obstruction which is actually being placed in front of it. So let's just try to take a look at this now. You can actually see the distance is actually 23 centimeters. On having to move this particular obstruction forward, you're going to notice a decrease in distance. As you can see on your screen currently, that you have there about 20. Moving it closer, it reduces definitely. And this particular sensing is actually very much accurate basically. So you move closer as well, it actually definitely gets reduced to there about 8 centimeters. If I actually kind of like bring it backwards a bit, definitely you're going to notice an increase in the distance based on what is actually being displayed on your screen currently, which is 17 centimeters. Taking it backwards further, you're definitely going to notice a slight difference as well, based on the fact that it increases with respect to the distance. Currently is actually 23. Moving it further, this can actually measure as long as 400 centimeters, that is 4 meters accurately, without having to have any issues, so to say. And this can actually be used when it even comes to automatic pump. That is to say, it switches on the pump when it gets to a particular level, then when it gets to another level, it switches it off. So it's really very much accurate basically. So that is just what an ultrasonic sensor actually does.